Alright, so hello and welcome back. So in this video we will continue with the matrices that we were doing in the previous videos, and in this video we will talk about the properties of multiplication of matrices. The properties of multiplication of matrices. So, the multiplication of matrices possesses the following properties, which we state without proof. There is, well, fortunately or unfortunately, there is no proof here, but we will get to learn a bunch of properties of matrix multiplication here anyway. So number one, the associative law. Number one, the associative law. And the associative law is that, of course, in the case of numbers, associative means, for example, a plus b plus c is equal to a plus, for example, b plus c. That's the associative law of, at least in addition. In multiplication, it's just simply multiplication. In subtraction, there is subtraction, but the base is basically this, right? Now, since we are talking about multiplication, of course, the associative law of multiplication in matrices would therefore logically be, for example, a times, for example, bc is the same thing as, for example, a times b times c, for example, something like that, assuming that these are matrices, and assuming that, for example, BC is defined and AB is defined, so based on the order of the matrices. So now the associative, you can say that for any three matrices ABC, for any three matrices A, B, and C, we have there is a E over here, we have AB times C, or AB times C is equal to A times BC. Whenever both sides of the equality are defined, of course. Whenever both sides of of equality are defined, right? And the distributive law for for matrix multiplication, number two is the distributive law. The distributive the distributive law is usually, for example, in the case of, for example, in the case of real numbers, you know that, for example, multiplication distributes over addition, right? But addition does not distribute over multiplication. What that means is that, for example, if I write a times b plus c, that is, and these are real numbers, then that's equal to ab plus ac. Meaning that you can multiply a by b and multiply a by c, and then add them together, and this way we say that multiplication, which is this thing over here, we say that multiplication excuse me, we say that multiplication distributes over addition, and this is addition. So this is, and therefore it is called, for example, the distributive law. Now let's see what that is in case of matrices. In case of matrices, you have A times B plus C is equal to A times B plus A times C, and also A plus B times C. A plus B times C is equal to A times C plus B times C. Whenever both sides of the equality, of the equality are defined. Now I did try to talk about basically how these make sense, but it's really not prudent to rely on common sense or anything like that, because you would need to basically prove these things. You cannot really rely on common sense. But as long as we know that they have been proved, although the proof has not been given here, of course you can use them. But it's actually not possible to talk about why why they are true, because at the end of the day they have to be proved, right? Now the third thing that we have here is called the existence of multiplicative identity. The existence of multiplicative identity, and that is for every square matrix A, for every square matrix A, there exists an identity matrix of the same order. There exists an identity matrix of the same order such that IA, the identity matrix, of course, has probably we have talked about this. The identity matrix is denoted by I of any order, of course, of order 2, 3, and so on and so forth, is equal to IA is equal to A. And the identity matrix is so that is the existence of the multiplicative identity. We will, of course, see a couple of examples regarding these 3 points here. So, so we have the associative law, which is A plus B times C is equal to A times B plus B times C. AB times C is equal to A times B times C. The distributive law is A times B plus C is equal to AB plus AC, and A plus B times C is equal to AC plus A plus BC. And the the existence of the multiplicative law is, of course, simple. I times A is equal to A times I. I made a mistake here. Is equal to A times I is equal to A, right? Now, we will now verify these using examples. Of course, the verification is no proof, of course. You already are aware of that. So the example number 16, we have if A is equal to basically a matrix of order 3, a matrix of order 3, 1, 1, negative 1, and you have 2, 0, 2, 0, 3, and you have 3, negative 1, 2, and you have another matrix B, which is basically 1, 3, 0, 2, negative 1, 4. That is your second matrix. And your third matrix is a matrix like this. So the third matrix is a matrix like this, which is 1, 2, 3, and negative 4. And you have 2, 0, negative 2, and 1. And you want to find basically, A times BC. You want to find AB times C, and you want to find and show that, basically AB times C is the same thing as A times BC, which is basically the associative law of multiplication in matrices, right? So now if I calculate A times, for example, A times BC, we have. Okay, so now in order to calculate A times B times C, I will start with B times C, and then I'll multiply A by the result. So that way I think it would be easier. So I erase this and I write B times C is equal to this matrix, which is 1, 3, 0, 2, for example, negative 1, 4. And then I multiply this by this matrix, which is 1, 2, 3, 4, 1, 2, 3, negative 4, 2, 0, negative 2, and 1, right? And then this is a 3 by 2 matrix. This is a 2 by 4 matrix. And therefore, basically the number of columns of this matrix is 2. The number of rows of this matrix is 2. They are equal, so that the multiplication, so B times C, or the product of the two, is defined, and therefore you would get a 3 by 4 matrix. A 3 by 4 matrix. So a 3 by 4 matrix means that you have 3 rows and 4 columns, right? So you can start from here, and I will start from basically this row and this column. 1 times 1 is equal to 1, and 3 times 2 is equal to 6. Then this row and this column, 1 times 2 is equal to 2, and 3 times 0 is equal to 0. Then this column, 1 times 3 is equal to 3, and 3 times negative 2 is equal to negative 6. And then you have basically 1 times negative 4 is equal to negative 4, plus 3 times, actually I'm here, so 3 times 1 is equal to 3. And that is basically the 4 columns that I have. So I can close this here, and that becomes my matrix. So I have 4 columns and 3 rows, right? 3 rows, 4 columns. 3 rows, 4 columns. So the second row, I can start from here, and the first column, so 0 plus 4. 0 plus 4. Then the second column would be 0 plus 0. 0 plus 0. The third column would be 0 plus negative 4. 0 plus negative 4. And the fourth column would be 0 plus 2. 0 plus 2. Now the third column, the third row is basically this row, and starting from this column, negative 1 plus 8. Negative 1 plus 8. And then you have, coming to this column, you have negative 2 plus 0. Negative 2 plus 0. This column you will get negative 3 plus negative 8. Negative 3 plus negative 8. And the fourth column is 4 plus, basically 4 plus 4. 4 plus 4. And so that is now a matrix of order 3 by 4. And so the matrix is actually nothing but 7, 2, negative 3, and negative 1, and a 4, and a 0, and a negative 4, and a 2, and a 7, and a negative 2, and a negative 11, and an 8. That is my matrix, which is the same, which is actually nothing but BC. Now 8 times BC, 8 times BC is the same thing as matrix A was. Basically this matrix 1, 1, negative 1, 2, 0, 3, and 3, negative 1, 2. And BC was basically this matrix, which is 7, 2, negative 3, negative 1, and 4, 0, negative 4, 2, and 7, negative 2, negative 11, and 8. Now this matrix is a 3 by 3 matrix. This is a 3 by 4 matrix. The multiplication is defined because these two numbers are equal, and you will get a 3 by 3 matrix. So a 3 by 3 matrix, I'm going to start with this row and this column, and you have 1 times 7 is equal to 7, and then 2 times 4 is equal to 8, and then you have actually I made a mistake here. So you have this row and this column. So 1 times 7 is equal to 7, and 1 times 4 is equal to 4, and negative 1 times 7 is equal to negative 7. The second column, the first row, second column, I will take this row and this column, so that's 2, and then you have 1 times 0 is equal to 0, and then negative 1 times negative 2 is positive 2. And then the same row times this column gives me That's actually a 3 by 4 matrix. I was wondering what is wrong with this thing. That's a 3 by 4 matrix, meaning that you will get actually a 3 by 4 matrix. So the third column here, you would get 1 times negative 3 is negative 3, and 1 times negative 4 is negative 4, and negative 1 times negative 11 is positive 11. And I wish we had more space here, but we don't. Now, I don't know what to do with this thing really. I'm going to write this down I'm going to write it as basically 7 plus 4 plus negative 7. And over here I'm going to write 2 plus 0 plus 2. I'm going over here negative 3 plus negative 4 plus 11. And then the fourth column I'm going to write here as this times this. So that's negative 1. That's negative 1, 2, and negative 8. And I will close this here. Then I will start from the second row, first column. 2 times 7 is equal to 14. And basically 0 times 4 is equal to 0. And 3 times 7 is equal to 21. Then 2 times 2 is equal to 4. 0 times 0 is equal to 0. 3 times negative 2 is equal to negative 6. So 4 plus 0 plus negative 6. So the next row, the next column is basically 2 times negative 3 is equal to negative 6. And 0 times negative 4 is 0. And 3 times negative 11 is negative 33. Negative 33. The fourth column, I'm going to use this column. So 2 times negative 1 is negative 2. 0 times 2 is equal to 0. And 3 times 8 is equal to 24. Then I'm going to move to this row and this column. 3 times 7 is equal to 21. Negative 1 times 4 is equal to negative 4. And 2 times 7 is equal to 14. Then I'm going to move to this column. 3 times 2 is equal to 6. Negative 1 times 0 is equal to 0. And 2 times negative 2 is equal to negative 4. Then I'm going to move to this column. I have 3 times negative 3 is equal to negative 9. And negative 1 times negative 4 is positive 4. And 2 times negative 11 is equal to negative 22. Then I'm going to move to this column. 3 times negative 1 is equal to negative 3. Plus negative 1 times 2 is equal to negative 2. Plus 2 times 8 is equal to 16. And I'm going to close this matrix here this way, and then we will add the whole thing together. So we will write it as, that is 11 minus 7 is equal to 4. That is 4. That is negative 7, so 11 minus 7 is equal to 4. And that is negative 9 plus 2 is equal to negative 7, I suppose, right? Negative 9 plus 2 is equal to negative 9 plus 2 is equal to negative 7, right? Then you have 21 plus 14 is equal to 35, is equal to 35. Negative 2, negative 33, negative, that's negative 39, negative 39, and 24 minus 2 is equal to 22. Then you have 14 plus 21 is equal to 35. 35 minus 4 is equal to 31. 6 minus 4 is equal to 2. And negative 22 plus negative 9 is equal to 31. Negative 31. Negative 31 plus 4 is equal to, what is 31 minus 4? 31 minus 4 is equal to 27, that's negative 27. And then you have negative 5 plus 16, so that's 11. 16 minus 1 is equal to 11, and that is your matrix. That is the matrix that we were looking for. That is the matrix that we were looking for. It's actually A times BC. That is A times BC. Okay. I'll make a screenshot here. If it's possible. And then we will continue with basically. So this one that we calculated was A times B times A times B times C. So now we need to calculate A times BC, AB times C. So now we need to calculate AB times C. Okay. Now AB times C, to calculate that, I will calculate AB first, and then we will calculate whatever we get, we will multiply it by C. So AB is basically, this matrix is 1, 1, negative 1. It's 2, 0, 2, 0, 3, 3, negative 1, and 2. And then we multiply that by B, which is this matrix 1, 3, 0, 2, negative 1, 4. And so this is a 3 by 3 matrix. This is a 3 by 2 matrix. These two numbers are equal. Multiplication is defined, and you will get a 3 by 2 matrix. So a 3 by 2 matrix would be something like this. So we will start with this row and this column. So we have 1 times 1 is equal to 1, and 1 times 0 is equal to 0, and negative 1 times negative 1 is equal to 1. Then you have this row times this column, which is 1 times 3 is equal to 3, 1 times 2 is equal to 2, and negative 1 times negative times 4 is equal to negative 4. Then you have this row times this column. 2 times 1 is equal to 2, this 0 plus 0, and 3 times negative 1 is negative 3. Then you have this row times this column, which is 2 times 3 is equal to 6, and 0 times 2 is equal to 0, and 3 times 4 is equal to 12. Then you can move to this row and this column. 3 times 1 is equal to 3, negative 1 times 0 is equal to 0, and 2 times negative 1 is equal to negative 2. And if you do this row and this column, you get 3 times 3 is equal to 9, and negative 1 times 2 is equal to negative 2, and 2 times 4 is equal to 8. And then what happens is that this is a 3 by 2 matrix, as we predicted, and so you can write it as 1 plus 1 is equal to 2, 3 plus 2 is equal to 5, minus 4 is equal to 1, 2, negative 3 is negative 1. 6 plus 12 is equal to 18. 3 minus 2 is equal to 1. 8 plus 9 is equal to 17 minus 2 is equal to 15. And that is your matrix, which is A times B. This is AB. Now AB times C is equal to AB, which is 2, 1, negative 118 and 115. And C is basically this matrix as 1, 2, 3, negative 4 and 2, 0, negative 2 and 1. And that gives you basically, this is a 3 by 2 matrix, this is a 2 by 4 matrix. So these two numbers are equal, so the multiplication is defined, and you'll get a 3 by 4 matrix. A 3 by 4 matrix, meaning 3 rows and 4 columns, right? So I will start with this row and this column. You have 2 times 1 is equal to 2, plus 1 plus 2 is 1 times 2 is equal to 2. Then you have basically 2 times 2 is equal to 4 and plus 0. And then you have 2 times 3 is equal to 6 and plus negative 2. And you have 2 times negative 4 is equal to negative 8. And 1 times 1 is equal to 1. Then you can move to the second row. And first column, 1 times negative 1 times 1 is equal to negative 1. And 18 times 2 is equal to 36. Second column, you have negative 2 plus 0. Then you have negative 3 plus negative 36. Negative 3 plus negative 36. And then you have negative 1 times, we already did this, and then this one, 4 plus 18. Then you have 1 times 1 is equal to 1, and 15 times 2 is equal to 30. Then moving to the second column, 1 times 2 is equal to 2, and 15 times 0 is equal to 0. And then moving to the third column, you have 1 times 3 is equal to 3, and 15 negative 30. And 1 times negative 4 is equal to negative 4 plus 15. Right, so that is the matrix that we have, and that is equal to 4, 4, 4, and negative 8 plus 1 is equal to negative 7. Then you have 35 here, negative 2, negative 39. 18 plus 4 is equal to 22. That is 31. That is a 2. That's negative 28. And that's an 11. And that is the same thing as AB. AB times C. So this is AB times C, and we wanted to show that A times BC, is equal to AB times C. Actually this way, times C. It's actually supposed to be this way. AB times C. So So what I can do is that what the screenshot that we had was A times BC was this matrix, and we wanted to show that that is equal to AB times C, meaning that I wanted to show that these two matrices are the same, and it seems that they are actually the same except for this negative 27 that I got here, which I might have made a mistake somewhere. I don't really know where. That's 27 actually. Negative 30 plus 3 is equal to negative 27. So that means that then the matrices are actually the same. Therefore we have shown that basically that is actually the case, and that shows that basically matrix multiplication is associative, and therefore matrix multiplication is associative, right? Is associative. So that was question number 16. Question number 17 is another example showing that matrix multiplication is distributive. So basically the distributive law for the matrix multiplication, and that is question number 17. And we have still some time to do it in this video. Okay, so now let's do example number 17, which is about distribution, basically the distributive law, meaning that in matrix multiplication distributes over addition. So what that means is that you can say that A plus B, or you could say also that no, but I would characterize this as multiplication distributes over addition. I would say it this way. So yeah, we have the same three basically matrices, and we want to show that, we want to verify that basically A plus B times C is equal to AC plus BC. Well, normally, if you have some number, if you had this equation and if these ABC were real numbers, for example, and if you had it in this way, A times B plus C, that would be AB plus AC, for example, and then you would say that multiplication distributes over addition. Now, I don't really know how I would talk about this, but still I would say that, basically in matrix multiplication, basically multiplication distributes over addition, but also that multiplication is commutative. No, it's not. It's actually not commutative. It's actually not commutative. So let's just simply not say anything, because if I want to say something, then I would get myself into trouble. I don't want to do that. So anyway, I basically want to show this, and basically this situation here has been called, in this text, has been called the distributive law, meaning that Well, of course, multiplication in matrices is not basically commutative. That of course we know. But what we know basically in general about matrix multiplication, if you have three matrices like A, B, and C, then we know that A times, for example, B plus C is equal to AB plus AC, and that is not equal to, for example, BA plus, for example, CA. That is of course there. And we know that A plus B, A plus B times C is the same thing as AC plus BC, and that is not the same thing as CA plus CB, right? So that is what that is called, and this has been called the distributive law. That is called the distributive law for matrix multiplication. For matrix multiplication. So that's what I can say. More than that, I avoid saying anything because again I would get myself into trouble. So now what I want to do is that I simply want to verify that A plus B times C is equal to A times C plus B times C, right? And the matrices that I have are A, B, and C. I will write them whenever it is necessary. So I will start from the left-hand side of this equation, and I will create it bit by bit, and then we will put the whole thing together. So now what is A plus B? What is A plus B? A plus B times C. Actually, A plus B is not defined. Oh, okay, sorry. Now, A is basically A plus B is equal to, this matrix is A0, 6, 7, negative 6, 0, 8, and then 7, negative 8, 0, negative 8, 0. And B is basically this matrix. Again, a 3 by 3 matrix is 0, 1, 1. Then you have 1, 0, 2. Then you have 1, 2, 0. Right? So that is that. So that's A plus B. And that is equal to, of course, you need to add the corresponding elements together, meaning 0 plus 0 is equal to 0, 6 plus 1 is equal to 7, 7 plus 1 is equal to 8, and negative 6 plus 1 is equal to negative 5, 0 plus 0 is equal to 0, 8 plus 2 is equal to 10, and 7 plus 1 is equal to 8, and negative 8 plus 2 is equal to negative 6, and 0 plus 0 is equal to 0. This is the matrix that we have. This is A plus B. Now A plus B times C, is equal to 0, 7, 8, negative 5, 0, 10, 8, negative 6, 0, and that you want to multiply by C, which is this matrix 2, negative 2, 3. 2, negative 2, 3. And so this is a 3 by 3 matrix. This is a 3 by 1 matrix. So these two numbers are equal, so multiplication is defined, and you will get a 3 by 1 matrix. So I will write this as basically this row times this column, 0 plus negative 14 plus 24. And then I will start from this row and this column, so that's negative 10 plus 0 plus 30, and then this row and this column you will get 16 plus positive 12 plus 0, and then you have, so 24 minus 14 is equal to 10, and 30 minus 10 is equal to 20, and 16 plus 12 is equal to 28. So that is A plus B times C. Now AC plus BC, we can create that also bit by bit, meaning that I create AC as basically A times C, which is equal to 0, 6, 7, negative 6, 0, 8, and 7, negative 8, 0. And of course, you know that this kind of work is always, I mean, once you know this, I mean, once you understand the basics of matrices, and once you know how to work with them, once you know the determinants and all of that, and all of the basic mathematics behind matrices and vectors and determinants and that sort of thing, then basically this whole work of calculation and all of that whole story is basically done by computers. There is all kinds of calculators, algebra systems, and that sort of thing that you can use on the internet, or as a part of a software package or something like that does this sort of work for you. You don't have to worry about multiplying and adding and subtracting and that sort of thing. But then in the beginning, of course, this is necessary in order to understand how it is done, and then you can give it to a computer. Moreover, now I wanted to say something else, but I forgot that. Now, so A times C, this is A, and C is basically another matrix here, 2 and negative 2 and 3. And so this is a 3 by 3 matrix, this is a 3 by 1 matrix. You can add them together. You will get a 3 by 1 matrix. So I can write my matrix like this. Start from this row, this column, 0 plus negative 12 plus 21, and then you have negative 12 plus 0 plus 24, and then you have 14 plus positive 16 plus 0. And if I add, basically close this, I can write this as 21 minus 12 is equal to 11 and 9, and 24 minus 12 is equal to 12, and 14 plus 16 is equal to 20 and 30. So that is A times C. Now, the next thing that we need, the next bit that we need to build is B times C. So B times C is equal to B, which is 0, 1, 1. This is 1, 0, 2. 1, 0, 2, 1, 2, 0. And times C, and C is basically this matrix, 2, negative 2, and 3. And you have a 3 by 3 matrix, 3 by 1 matrix, so you will get again a 3 by 1 matrix. So I will start from this row and this column, 0 plus negative 2 plus 3, and then I have 2, 0, and positive 6. And then this row is 1 times 2 is equal to 2. 2 times negative 2 is equal to negative 4. And a 0 here. And that is equal to 3 minus 2 is equal to 1. 6 plus 2 is equal to 8. And that's a negative 2. And that is basically B times C. Now, over here I need to calculate A times C plus B times C. So A times C is this. A times C and B times C is equal to this matrix. So I add them together. And adding is, of course, commutative, meaning that you can write A times C plus B times C or B times C plus A times C. That would give you the same thing, of course. So 9, 12, 30 plus 1, 8, negative 2. That gives you, I would write my matrices without these, but then that would create a problem. So that's a 10, that's a 20, and that's a 28. Now, this is A times C plus B times C. Now, we had, so you can see that over here, you can see that we wanted to show that A plus B times C, which is this thing over this matrix over here, is equal to AC plus BC. So you can actually see that this matrix 10, 20, 28 is exactly equal to AC plus BC, which means that A plus B times C, A plus B times C is actually equal to AC plus BC. That is what we wanted to show. So, and that we call basically, that we call the distributive law in matrix multiplication. Now the next example that we have here is example number 18, and that is if A is equal to a matrix, a 3 by 3 matrix of 1, 2, 3, 3, negative 2, 1, and 4 to 1, and you want to show that A cube, you want to show that A cube minus 23A minus 40I is equal to 0. Not 0, but O actually. There is no 0 in matrix actually. So That's O, which is the zero matrix, of course. So, but we have no time for this right now. We will do it in the next video, and see you in the next video, and thank you.